And it's time to get started. Welcome to this week's episode of Clemson ACM gives a presentation on something cool involving computers. My name is Austin. I'm the president of Clemson ACM. This is Robert, my evil vice president. And today you're going to learn a little bit something about Git. And we're going to explain what it is and why you should care in a few moments. Now, the focus of this presentation, or the schedule, is going to be, first off, we're going to tell you what Git is, what sort of software it's a member of, why you should care. That's a really important part. How you can get started. We're going to have lots of puns involving the word Git. And finally, we're going to wrap up, give you some quick suggestions on how to learn more yourself and that sort of thing. So first of all, what is a Git? What is this thing? Is it an unpleasant person, as the term Git usually refers to? No. Even though Linus Torvalds, who started up Git for the Linux kernel, describes himself as a Git, and I think that's why he named it Git. Git is actually a free, open source, distributed version control system for programming and other project things that can be source control. It's free as in a free lunch. It's free as in open source, as in Linux. It's really pretty cool. But again, what the heck is a distributed version control system and why should you care? Imagine the following. You're working on a project. Maybe it's the ray tracer. Maybe it's something for CPC 212 with algorithms or something. Imagine you have decided that it's probably a good idea. Hello, you're late.
I was sorry.
It's probably a good idea to start backing up your code and saving snapshots or something to try and make sure that if you accidentally overwrite your files, it's happened to the best of us, that you'll actually have something to go off of. Well, that's kind of fine. You're going to save several different copies of the same thing. You might overwrite or delete your backup. It happens. It's a mess. Now, what if you want to instead try new, different things with the code you're doing? Maybe you've worked on implementing some sort of the project that you're working on in a specific way that you decide you don't like anymore, and you want to do something different. Then what do? You maybe save your old code and start writing new stuff. You maybe just started writing the new stuff and deleting old stuff, and then realize you want to go back to the way you had it before. And it's a mess, and you cry, and you get a bad grade. What if you find a bug later? Where did it come from? I don't know. And then what happens when you're trying to do something on a group project with sharing code, God forbid? You have to email back and forth. If someone changes something about a certain file and you also change something about the same file, how are you going to get it together? You're going to have to merge it and diff it and patch it and do all sorts of weird, awful, horrible things that you just wish you didn't have to do. How do you make sure everyone in the group all has the same code base to work with? How do you know someone isn't working with an older version of a certain file? What do you do when someone new joins? They need to get in on the whole business. It's, again, a mess. And this is pretty much where distributed version control comes in, or just version control in general. The basic concept behind version control is you store files to repositories. They can be local, they can be stored in the cloud, but the repository manages handling all this stuff for you. It tracks versions of your code. It remembers when you change it, what you changed it to, what things changed, all sorts of useful things that you're going to care about once you start trying to move around in your code base. It provides tools, most version control systems do, maybe not older ones, for finding out when bugs came into the code. If you realize that something appeared and you're not sure where it came from, you can find out who wrote a specific piece of code if it's particularly ugly or has a bug in it and you need to fire them, I guess, or punch them in the nose. It's useful for managing older versions of code or restoring older versions where if you realize that you don't like the changes you've been working on for the past day, you can go exactly back to where you were before you started working on them, as long as you committed them properly to the repository. You can merge different versions of code together to keep all of the stuff you like the best. There are functionalities for doing all this sorts of stuff without having to figure it out manually. And there's more. It's cool stuff. You can have new team members just clone a copy of the repo that everyone is looking at. Repo is short for repository. You make sure everyone is up to the same level. Now we're getting somewhere. I'm sorry about the puns.
So you're probably wondering at this point how to actually get started. So the first thing you're going to want to do is set up some information that Git will associate with each commit that you enter.
Now I do want to interrupt for a minute. We've been talking about version control systems in general, specifically, not specifically. We're going to be talking about the version control system Git a lot. It is one of our favorite version control systems. There are others: Perforce, CVS, SVN, Mercurial. They all have their benefits, except maybe for CVS. But in particular, we're talking about Git.
Okay.
Back to you, Robert.
So the first couple of things that you're going to want to do is you're probably going to want to tell Vim some stuff about yourself. Let's start.
Git.
Yes, tell Git some things about yourself. So first thing you're going to want to do is give it your username. For this instance, we're setting it up for Austin over here, so he's Mr. President in all of his commits. And then he would say that his email is acm@clemson.edu or acm@cs.clemson.edu.
All of these computers do have Git installed, right? So
Yes.
you can do this sort of stuff on your computer as you follow along.
Yes, we do encourage you to follow along. So Austin definitely does not like Emacs for editing his commit messages, so he's going to tell Git that his preferred text editor is Vim, none of that Emacs garbage here. And he can also say things like, hey, color my outputs so I can actually identify changes easily in my diffs. So that's basically what you're going to do. So there are two ways to start working on a project. The first way, Git init, is how you start on a new project that no one else has worked on before. So we're going to demonstrate this in just a moment. The alternative option is Git clone, and you pass Git clone a URL, and that URL corresponds to the project that you want to clone. Some of you may have heard of GitHub. And
it's not the same thing as Git.
Yeah. And on GitHub, there's going to be a URL that says clone this repo or fork this repo, something of that sort, that you can copy and then pull it down to your own machine. So that's basically what you're using, is you're using git clone to pull down a copy of that repository. So let's look at how you actually start creating a repository.
Now this is something you can do if you're just starting out with a new project, or if you have a project that you've been working on for a while and you want to turn it into a Git repository.
Okay. Can everybody in the back read that all right?
Pretty good.
Okay. So we get this message, initialized empty Git repository in location. So, and my prompt is set up to show me what branch I'm on. We'll talk about branches in a little bit, but now we've created this repository.
Now that .git folder referenced is where all of the information for that particular Git repository lives. Generally, you don't have to worry about interacting with the .git folder unless you're doing something wacky. It's a hidden folder. It won't show up in a lot of different things. It manages itself.
Okay. So the first thing that we're going to want to talk about is adding some files. So every good project needs a README. So we'll open up our favorite text editor here. And we'll go ahead and put some initial text. So if we look now, you'll notice that my status flag has changed. But you'll also notice at this point we haven't actually saved the changes to the Git repository. It's currently in what's called our working copy of the file. So if we want to add a file to our working copy, we're going to use the git add command. Now, even if a file has already been tracked, if we want to add a collection of changes to the repository, we're going to use the git add command to do so. So
now to explain what all this tracking business is, you have to tell Git specifically which files you want it to track version information for. By to do that, you will add it. You'll specifically tell it with add that you want it to track this file, and it will then be watched in the future. But you also have to tell it every time you want to commit a specific version of that file. It won't be automatic whenever you save it or anything. I think we'll mention what a commit really is in a few minutes also.
Yeah. So at this point, we see that we've looked on git status. That will tell you the status of your repository. So we see in this case that we have an untracked file called readme. So we can go ahead and add that file by doing a git add readme. Hit enter, and if we do git status again, we'll see that we now have a new file that is ready to be committed. So let's go ahead and commit that file. So we type git commit. It'll open up our favorite text editor, and we can say starting a new project. And then when we close the text editor, it'll say that we have now made a commit. This commit is the root commit. It'll give us our commit message. It'll tell us how many files we've changed and how many lines on that file we've changed. So that's what we've done at this point.
Now, why don't you, when does git log come in?
I believe next.
Next, okay, cool. We can show you the log.
So we want to look at the log. We can do type git log, and it'll show us a list of previous commits. So there's a couple different things on this line that we want to talk about. First, you see the word commit followed by a string of garbage. That string of garbage is actually a hash of the changes that were made in that particular commit, and it's a good way that Git uses to refer to a specific set or collection of changes.
It's basically just a unique identifier for the set of changes that represents this particular snapshot of what you're looking at.
Yeah. So the other thing we'll see is we'll see the author, we'll see the email address related to that author, we'll see a date or a timestamp based off the computer that the person was using when they made the commit, and then we'll also see their commit message. So if you want to get an idea of what's been going on in a project, looking at this is actually a pretty good way to do it. So after we've done that, we may want to see, for example, a list of changes. So let's edit our README file. So we've added some important stuff to the repo. And you notice now my status bar has changed again. And this particular status bar indicates that we have some changes that have been added. So let's do a git diff to see the differences between our previous version and our current version. You'll notice that we now have some green text that says added some important stuff to the repo. If we make any changes that remove material, when we look at it again, you'll see that it will show in red the line that we removed, followed by green with the line that we just added. So let's say that we didn't like that particular spelling mistake there. We can fix it back and look at our diff, and it's back to the way it is. So at this point, we probably want to go ahead and make another commit. So we do a git add, and then git commit. So you may see people occasionally add a -m flag to their git commit command. That allows you to basically enter a commit message without opening your text editor. So if you're trying to make a quick little commit, like you fix some white space or something like that that doesn't really need a couple paragraphs to explain or a couple sentences to explain what you did, you can do stuff like added more details, and it'll tell you that we've committed. It'll give us a little bit of the hash identifying that specific commit, and if we look at the log again, we'll now see that there are 2 log entries in the git log. So the next
in this way, you can track your development over the course of working on a project to identify when you added stuff, or if you're having multiple people work on it, who added certain things and who yell at it that went wrong.
Mm-hmm. So if you want to see, for example, what specific files were added at a specific time, you can tack on the --stat option, and it'll tell you which files were changed and how much stuff was added to that file in each change. So for example, if you're working on a Java project and someone commits a bunch of .class files, you know exactly who to yell at for doing that. Likewise, if someone adds a bunch of gedit temporary backup files, you can find out who did that, and you can easily go in and remove those also. So now, let's say that we want to know what lines were changed in which commits, or possibly who even changed them.
This might come up if you're working on a big group project or on a company project and you have this file that's been in development for like a year and there's been dozens of different people working on it, and you find one bug and you want to know who made it.
Helps when you actually give the correct command. What?
You're the one to blame.
It was Robert.
Yes, I am the one to blame here. So this looks a little awful because of the fact the text is blown up so big. But what you see is it gives the commit hash, who gave the commit, the date, the time that it was committed, and then the specific line. So this is based off the current version. We can see when specific items were introduced into the code. The next thing that we probably want to look at is getreflog. So getreflog looks at we're going to talk a little bit more about branches in a minute, but it looks at where you were working last and kind of keeps a track of that information. So if you can't remember what projects you were working on recently, you can use getreflog to see which branches and which sections of the code you were working on. Or if you reviewed someone's changes, you can go back to a specific commit that you reviewed. So that's kind of what reflog does. Also, if you do destructive stuff to the Git repository, like removing files and stuff, and you're not sure how you did it, getreflog will keep a track of that commit hash, and you can actually use that commit hash to sometimes recover the files that you lost. So reflog is definitely a very useful tool to know about. So let's say we made a mistake and we don't really want to have the current version we have. So we can look at a git log, and let's say we wanted to go back to this commit. So we could grab a bit of the hash, we could do git checkout hash, and it'll say that we are currently at a detached head state and we are looking at a particular version. So if we look at README at this point.
We'll explain what the detached head is in a minute. It's not like being decapitated or anything.
Yeah. You'll notice that the important stuff that we added in our last commit is no longer there. That's because we are currently looking at our original commit. If we had 5 or 6 different commits, we could look at a bunch of different commits one at a time. So that's roughly what happens when we check out. You can also use checkout to look at different branches, more on that in a minute, and also to look at different versions within different branches. So if you ever need to get back to the main place where you were editing last, you can do git checkout head in all caps. Excuse me, that won't work.
That was wrong, Robert.
Git checkout.
Looking for master?
Yep. And that'll take you back to the head of the master branch. We'll talk about master in a minute. So let's say that we made a mistake and we really want to go back to a specific version.
Now, we already saw jumping back to what our code looked like at one point, but what if we want to just make it so that these later commits that we no longer want are just undone? Make the version before the official, this is where I'm starting from point. That's what these commands are useful for.
Yeah, so we're going to go ahead and do a git revert. So what it did is it did a merge, so we can go ahead and talk about merge conflicts, I guess. And we'll see that we have some lines that we can remove at this point. But git revert basically allows you to clear up and go back to a specific commit. So basically it takes all of the changes from a current commit. You have that marker that actually works. Awesome.
I do, somewhere. Yes.
So let's say you have a bunch of different commits.
Can anyone see that? No? Okay.
Yes.
So let's say that we no longer want this commit to be our version. Git revert allows us to grab this version and pull a copy of it up to the front. So are there any questions about git revert? By contrast, git reset doesn't kind of cross out this commit and leave it in place. Git reset just forcefully moves the head pointer to a specific location. So in this case, we went back to head. We're no longer in that conflicted merge state that we were in earlier. Yes?
So basically, we now have that garbage just kind of sitting there.
So git reset just goes. Git revert keeps it in the list of changes. So if you ever need to go back there for some reason, it's still there.
Okay.
Also, if you're working on a repository that's a public repository, it's generally frowned upon submitting a version that reset to someone else's public version. Using reset within your own development's okay, generally speaking. It's a really easy way to clean up when your repository gets in a corrupted state like we just showed. But if you're working in a large public thing like the Linux kernel or something of that sort, you want to generally save revert. You want to generally prefer revert to reset.
Hopefully you won't run into any of that because it takes some getting into, and by that time you're going to be a Git expert.
Yeah. So, any more questions about revert or reset? Okay. So, Austin's going to talk about what a branch is.
All right, so we've been talking about these things called master. We've got this thing called head, and there's detached head somewhere, and I don't want to lose my head over any of this. What are these things called branches? They're a really useful concept that it's like a branch of a tree almost. The way that Git visualizes its commit history and the way that a bunch of commits interact with each other or are branched from a single parent is via branches, like a tree. So a good example of how these things work is that, say you're working on one of these projects like I mentioned, maybe the ray tracer, and you've written a lot of functionality and stuff, and you realize that you did something in a way that you don't like anymore. And you want to start recoding a bunch of stuff in a different way. But the problem there is that if you ever decide to go back, or if you realize that it wasn't a good idea after all to change all these things, then you're going to want to go back to the way it was before, and that's going to be kind of awkward if you have to search through your Git log and find out where you started changing things. It's going to get awkward. This is where branches are useful. So a branch is something that you can explicitly declare as a separation of where your commits are going. So you can say at some point, all right, here's a branch where I'm going to go and delete all this old stuff and start doing it differently. Then if you realize that that was a bad idea, then you can go back to where the branch started because you give branches a name and everything. And you're just fine. All that code will still be there and it's good. Another neat thing about branches is that if you do development in a branch and then do development back where you started, then you can merge the two together once you're finished with some automated tools so that you'll end up with something that incorporates the best of both easily.
So we'll demonstrate that in a moment.
Right. Now what are these things like master and head? Master is your master branch, to be to the point. It is an indicator of the canonical code that you're doing. It's pretty much the master version, if there aren't any better words for that. It's stable, it's final. It's supposed to be the shareable product that you're finished with. You can, generally you want to be careful if you're working in a project that has a bunch of branches about working directly on master. It's become sort of a thing on GitHub to make a branch for your own changes and then submit a pull request to have them merged into the master branch of whatever project you're actually working on. Branches are useful for team they're useful for team projects. And you should be careful to test anything that goes into master. It's important. Head is the branch that you are currently at. Head is kind of hard to explain without going into the nitty-gritty details of exactly how Git works. We'll give you some resources on that later because it'd be a really odd presentation. Head is basically where you are at the moment. It is a pointer to a specific commit, and you can work from there. Robert has pictures.
Yeah. So if you think about this, this line right here could be the master branch. And this could be the Annoy Austin branch. So in this case, the Annoy Austin branch is just kind of a pointer to here. And then master is really just a pointer to right here. Okay? So let's say that you were looking at this version right here. In that case, head would be right there.
Now each of these circles is one of the log entries of a commit, basically.
So, and if we use get checkout, we can move head to say right here.
And then the local copy of the files you're working with will be representative of the stuff that's in that commit.
Okay. So does this picture help any?
No, it doesn't.
Okay, cool. So let's talk about actually making some branches now. So we talked about making a branch, so let's do get branch. And right now you'll notice that that lists just one branch at the moment. It lists the master branch. So if we want to make a new branch, we can do get checkout -b for branch, and we'll call this one Annoy Austin.
Yeah.
So we've now switched to a new branch to Annoy Austin. So we can edit our README file.
Austin is dumb. That's not very annoying. It is pretty annoying. I'm annoyed.
Yes, I intentionally misspelled Austin's name and didn't capitalize it.
That is how you spell my name.
That is like spelled.
Okay, now it's misspelled.
Are you trying to spell autism? Wow, okay.
So let's say that we want to add that annoying change, so we can do a get add readme, and then a get commit annoying change. Okay, and now we see we've made a new commit to the Annoy Austin branch. We can now go back to master.
What's this code, Robert?
Okay, so I've made an alias for checkout to CO because you use it a lot. It's pretty easy to do that. You can look at the git config command in order to add aliases.
We'll talk a little bit more about this.
No, I
It's not
really
as smart
don't.
as SVN.
I really don't like SVN, but I don't like typing out checkout every time I want to change branches.
Sure.
So
It isn't as smart as SVN is about figuring out what.
yeah. So where did our changes go? So basically what we did is we were right here looking at a different version where we added some stuff to Annoy Austin. And when we checked out master, we went back over here to this head branch where we hadn't made those changes. So then if Austin doesn't, for example, approve that pull request for whatever reason,
No way.
we wouldn't go on with it. But just for examples, we can actually go ahead and edit the README file here. And let's go ahead and add helpful stuff to the master.
Are you going to be merging those two branches?
Yes, I will be.
Uh-huh.
So you notice I use the flag -am. So A says add all modified files that are tracked, and M is for a message. So that way I don't have to use the get add command.
Now, using the -a won't do anything to files you haven't done add on before. So
Yeah.
if you haven't told Git to track a file, the -a flag won't help.
Yeah. And in general, you probably shouldn't use the -a file because you may accidentally end up adding stuff you didn't intend to add.
You can do it. Don't listen to Robert.
But if you're making a small change like this, it's a quicker way of doing
You're
things.
empowered. You do what you want.
So now if we go back to the
Now we have these two branches with conflicting information in them, and we want to turn them back into the one single unified branch of master.
so we go back to master, and then we can do a get merge Annoy Austin. Oh no, we have a merge conflict. So a merge conflict is basically when two people have edited the same file on different versions of the file.
This is when you abort and go home. No, it's not.
Yeah. So we can edit the file, and you'll notice that it has put in some markers to show us what kind of changes we've made. We see one marker for head and another one for annoying Austin. Well, obviously the annoying Austin stuff doesn't really need to be there as much as it breaks my heart. So we can remove those lines. We add the README file again, and then we can commit and say resolving a merge conflict. So that's how it works. If you wanted to, for example, leave the word annoying or something of that form, you could have done that. All you would have done is basically, instead of just choosing the nicer, helpful version, you would have left whatever words you wanted from Austin's version in the text. So let's talking about sharing code.
Sharing is caring, usually.
Yeah. So how many of you have heard of GitHub? Okay. So GitHub is not Git. There's a very important distinction here. So Git is a program. GitHub is a collection of servers that run the program Git.
Basically, it's a host for your repos if you want to push them online.
So
Great for code collaboration and working on all sorts of stuff together, and really cute mascots, but that's beside the point.
yes. You may have also heard of something called Bitbucket. Bitbucket is very similar to GitHub. They're slightly lesser well known. They're more popular in the proprietary software world because they allow you to have private repositories instead of public repositories for free. So use them for different purposes. So if you're working on a lot of public open source projects, do most of your stuff on GitHub. If you have a couple private projects, like you have to keep your code for class projects private, they would probably frown if you published your ray tracer on GitHub.
Actually, with the GitHub Education Pack, which all students get, you can have free private repositories.
Yeah, but you're limited to 5.
That's plenty.
That's really all you need. You just keep running a bunch of branches.
If you like,
There is also a service that the School of Computing has set up called Buffet. I think we'll make sure you guys have access to it. We'll send it out in an email if it's not on this. It is a Git and SVN host for Clemson School of Computing students, so that you can have a remote repository host for your stuff. The reason you might care about that is if your local files get corrupted somehow, even the Git directory is not safe, so it is useful to have a remote backup. It's handy.
yeah. Also, in the unfortunate event that a building burns down that has your only copy of the files in it, you're still safe. So it's pretty easy to set up your own Git server. I actually did it. It takes about 5 minutes, but it's probably not what you want to do every day. So setting up this network portion of Git is pretty easy. You do git remote add origin. So that says a locate. We're going to add a location and call it origin. That is not on our machine.
Origin is kind of the go-to name for a remote thing.
Yeah. Yeah,
All remote.
I could say, let's say I knew Austin's IP address. And we can see that we now have one remote. If we had, for example, a Bitbucket account or a GitHub account, we could also do git remote add origin bitbucket.org:/
All of bitbucket.org.
stuff. We're not actually going to push anything to this right now, but if we look at our remotes list again, we see that we now have 2 different remotes.
You can have as many remotes as you want, so it's useful to back up and collaborate and do all sorts of stuff. There are a lot of services that work by hosting Git repositories, like Heroku does that.
Mm-hmm.
It's pretty cool, even though I haven't really gotten much into it.
Okay. So once you're finally got all those changes added to your remote, it's probably time to share them with someone. So this is probably the one time when pushing is okay. It's okay to be pushy. Because when you push, you're sharing your changes with the world. So you'll notice that I've added git push-u. That will set what's called the upstream branch. So for each branch that you have on your list, you can have a remote associated with that branch. And what that will do is ensure that those changes for that branch get pushed to that remote location. And then after you've done that, you can just use git push, and it will remember the fact, oh, this was the remote location that we're using for, say, the master branch.
Now, sharing is not always caring, as I asserted just a moment ago. You might be tempted to add certain files to your Git repository and maybe push them that really shouldn't be shared. These are things like API keys, anything that involves passwords, or other things that should not be given to other people that are not you or members of your team.
SSH private keys.
Yeah, that too. That also, if you do these sorts of things, in certain cases it may also be a breach of academic integrity, which we will not get into because it is confusing. So in these cases, when you definitely do not want to share certain files, there are mechanisms by which to do that. If you'll go back to the slides, please, called the git ignore and the core.excludes file for git. Mostly you can just use git ignore to ignore things. Then it won't show up when git yells at you that there are certain files that have not been tracked. It'll just be invisible to git and it won't try and share things. It's pretty cool. Here's an example of the git ignore. A good example is if you're compiling things, as you might often be doing in computer science, you probably don't want Git to tell you that you should be tracking a.out, or the name of the executable that you compiled. In that case, you can add a or *out, I think he did, to the git ignore file, commit the git ignore file so that Git remembers it, and then it will use anything in that git ignore file to selectively filter out files that it should be ignoring. So as you can see, if you, why don't you do ls, or create the status. There's nothing to commit. We have an a.out, but you didn't add it to the tracking or to git. It's just git things. It's not there. It's nice and handy to clean up the git status list, and like I said, it's great for hiding things that should not be shared with other people.
Yeah. If you find that yourself entering the same thing in a git ignore file in a bunch of different repositories, that's where the core excludes file comes in. Think of it as a global.gitignore for all of your repositories. It's a really useful file to set up, especially if you're doing a lot of stuff in Python or C. So, merge conflicts. We already handled one of those earlier. If you have a particular GUI tool that you like to use, like Emacs or Meld is my personal favorite for handling.
WinMerge on Windows.
Yeah, Meld actually can run on Windows also. But what Git merge tool does is instead of having to fix that merge manually by ourselves, Git merge tool will open it up in our favorite editor of choice for doing our merges, and will allow us to merge each file one at a time. So it's a pretty useful thing to know about. It makes merges a little less painful, because merges can be at sometimes very painful things to do. Don't forget to retest before you merge changes.
If you do have tests. We don't have a seminar on unit testing.
We need to set them up. Yeah. So don't forget to test your stuff. At very least, recompile whatever thing that you just did and make sure that it compiles cleanly after making a merge.
And before submitting, and before going to bed, and before breathing. You just test all the time.
So that will help maintain sanity when you're editing your files.
Now, what happens if you decide that Git is not powerful enough for you? You want advanced code collaboration. You want to be the driving force behind all that is good in the world of code. Well, maybe you can, maybe not with Git. There are some hosts that provide like wikis for the code base that you're working on. They have issue trackers for watching issues, like submit bug reports, add feature requests. GitHub has great functionality for both of those things. They all use Markdown and really cool emoticons. Pull requests, we already briefly mentioned them. They're a way to say, hey, I want to contribute to this. Here's what I've done, and here's why you should add it to the project. It's great for open source and collaboration and keeping things separate from just the master branch. It's pretty useful. There are these things called Git hooks that are basically tasks to execute whenever Git does something. So you could say, whenever I push to this repository or whenever I commit a change, I want these tests to be run on my code. So you can automate things without having to add another automation command. You can do it right from within Git. That's really cool. We don't have a whole lot of content on it. There's more in the Git book, which we'll be talking about in a few minutes. You can create your own commands by doing aliases and mixing things together. You know a little bit more about that. I think Robert does.
Yes. So creating your own commands and aliasing stuff with Git. So Git has two different categories of functionality. It has what are called plumbing commands and what are called porcelain commands. The plumbing commands are really nasty. They do lots of crazy things, and there's a lot of power there to be had. Most
Behind
of
the scenes, you don't need to worry about it usually.
Yeah. And you can actually string these together to implement your own version control system if you're particularly crazy. Plumbing or porcelain commands are the nice, easy to use ones. Examples of that would be checkout, pull, add.
The stuff we've been showing you mostly
is porcelain. So you can kind of use these different aliases and these different commands in order to string together some of these plumbing commands that we talked about in order to do more powerful stuff.
More power can be found with editor extensions and plugins like Fugitive for Vim or Git Gutter that will show like change lists and let you do things from within your editor. A lot of editors and IDEs have Git-based plugins that you can just do things from within the plugin, within the editor instead of having to go back to the command line. Here's an example of Fugitive. It's made by Tim Pope, a guy who does a whole lot of stuff for Vim. He's kind of a monster in a good way. And of course, there's always Git help for learning more. Might not be the most extensive and easy to read resource, but it is always there for you. Foster says it's pretty nice, so it's pretty nice.
Yes, and I actually like it a lot also. You may spend a little while looking for the specific command that you need, but once you've found that command, you can do lots of really useful things with Git help.
Now, in case you have a terminal allergy, then you can also use a bunch of GUI tools. I think, Robert, you actually know more about them than I do.
Yeah, so GitHub, from what I've been told, has a wonderful desktop client. Bitbucket has a pretty decent desktop client for managing your Git repositories. I haven't used those very much myself, but I've talked to people.
GitHub's clients are for both Mac and Windows.
Yes.
There's nothing for Linux, right? Okay. If you're Linux, you're out of luck. You've got to look elsewhere than GitHub's desktop client.
Yeah. Yes.
Yeah, the command line's easy.
Yeah. There's a wonderful program called Meld, which makes it really easy to handle merge conflicts in your code. I love it. It's one of my favorite commands. Unfortunately, it is not on the lab machines by default, so you're either going to have to go into /configure territory and compile it yourself, or find one of the other various different tools that are available on the lab machines. I would highly recommend gvimdiff, and emerge is the name of the Emacs equivalent of gvimdiff for keeping track of your different merge conflicts.
Now, to wrap up, we are pretty much past all the introductory stages of what Git is. It's still a pretty confusing topic. I had to read the Git book about 3 times before I figured out what all this stuff was, and we're trying to dump it all on you in an hour, which is why we're going to recommend some things later after we talk about the summary. Please use version control. Please get used to it. It is extremely useful. It's not really that much extra work, and it can save you a lot of stress in the long run, especially once you have to learn to use version control once you get into a company, because they all use it. Maybe they use CVS or SVN or Perforce, that's a big one, Git. A lot of companies use version control to manage everything because it's a great idea. Yes? Mercurial is another good one. Thank you, Foster. What?
Handon uses it.
Handon, that's right. I forgot to talk about Handon.
It's pretty great.
The Clemson's own Handon system that you might have used for turning in computer science projects actually uses Mercurial as a backend. Mercurial is another really nice, easier to use, kind of like Git, version control system. So they're all over the place. you can spend the time to get used to one of these, like Git or Mercurial, and it'll save you, like I said, tons of time. And you can work on the time, like, actually doing code instead of figuring out where your bugs came from and how to fix them and how to go back to the code you wrote 3 days ago. Now, these resources that I keep talking about. First is the Git book. It's called Pro Git. It's by Scott Chaikin. I think that's how you pronounce his name. It's on the Git website. This is a link. We'll send this presentation out. We'll also send a bunch of links, I'm sure. It is an excellent resource. It is totally free. You can download it in a bunch of different formats or read it online. It does a great job of introducing the things that we tried to speed over. So if you're confused and you want to learn more, go and read the Pro Git book. We have a cheat sheet. There are a lot of cheat sheets. Having a cheat sheet for as you're getting used to Vim will be really useful. I mean, Git, I did too. Git. So that'll be a useful resource. We also have workflows. I think that's by
Atlassian.
Yes, Atlassian. The company makes Bitbucket. Why don't you talk about what those are?
Okay. So we've kind of talked about what Git is, and we've kind of introduced what I would call a single developer workflow, where you're kind of working along on your own project and you have to make a couple changes here and there. Once you start working with bigger projects, it's important to be doing your version control in a disciplined way. So this resource talks about 3 different prevalent workflows in the version control community and how you can get started using those. And then lastly, we would recommend that you check out Mercurial if you're looking for something that's not quite as command heavy as Vim.
It's a little
Git.
Git.
We're all on this Vim mode today.
Mercurial is reputably a little bit simpler, easier to get used to than Git. It has some more easy to understand commands, and it's not so odd as Git is in some ways. They both have their benefits, to be sure, so take a look if you're interested in learning more about version control, but Git just sounds like it's too much for you. Now, that wraps up our presentation. Are there any questions before we go into our final closing comments? Yes, Dalton.
So let's say we set our origin to be Austin's IP address. What would that happen? Like, could I just keep sending stuff to his IP address without him knowing?
It probably wouldn't work unless I had to get a server set up.
Yeah. So if Austin has it set up on his machine to accept Git requests that happen to be a loopback address, so it's actually not going to even make it off my machine.
Yeah.
But if we had set it up to, let's say Austin had a server on the cloud, he could have it.
Austin Hub.
Yeah, Austin Hub. So we could add Austin Hub to our origins list and put in the IP for Austin Hub. And if he has set up his Git server side stuff correctly, when our machine shells over to his machine is like, oh, you have Git commits, I'll take those, and then it'll put it on his machine.
Otherwise, it'll probably just ignore you.
Yeah, or give you this nasty packets rejected by host command.
In that case, could you just spam the thing if he's still going to have to process it either way? Could you just sit there spamming?
Are you trying to do like spam?
Yes.
Well, I mean,
Yes.
It's not a very effective way to DDoS someone.
Yeah, there are way more effective ways to
Yeah, but I figured it's still something.
It's still something, but there are much more effective ways of spamming
It
someone.
probably won't be that effective because I'll just be ignoring the packets. It won't like try and interpret all of them.
Try on my computer.
Yeah.
Are there any other questions? Yes, Rusty.
Was that Emacs OS thing a dig at Emacs?
Yes, we don't like Emacs.
Okay, I just wanted to be sure.
It's true.
Yes.
Anyone else?
As you can tell by all our Vim
Unless you
comments.
like operating systems and tech centers.
Yeah, if you haven't guessed from all of our slip-ups in calling Git Vim today,
Yeah, we like Vim.
we really like Vim.
It's kind of our favorite thing next to Git.
So if you missed our seminar last week, you should definitely check it out. We've posted the video online for that. So if you want to learn more about the wonderful text editor that is Vim, feel free to check that out.
No more questions? One more time? Last chance?
Where do we go for all these links that you're talking about?
We will
All right,
send
I
this
was just about to
presentation
get
out.
into that. We have a mailing list, and if you're not on the mailing list and you would like to be, because there are a bunch of reasons I'm going to introduce in a moment, then you should come and talk to us. Being on the mailing list means that you hear about all sorts of our cool events, like more of these, our LAN parties, our professional events, information about these seminars if you missed them, links, videos, recordings, bad puns, all sorts of useful stuff.
The cookie breaks.
Cookie breaks, yes. So if you're interested in getting all these links that we talked about and being able to access this stuff, please come and talk to us. We're friendly. We will get you on our mailing list, which you can leave at any time. You can just yell at us to get you off, and we will help you out. Anything else? Excellent. That wraps up the presentation, I think. Anything else from Robert?
Nope.
All right.